Well, here we are, not one but three boxed Eurosonic, the EU40. Don't be put off that the EU40 is in fact a 2781 set, it isn't a EU set. I think we've got one, currently we've got a DNTH2 4000 EU only set, which will be quite novel testing around here. I'll probably get about half a mile on it before I get foreign interference, but we'll see. So, there's three sets here in, I presume he's got them off eBay, and here we go. Last week I acquired three Eurosonic EU40 2781 handsets. Each came with original boxes and relevant paperwork, and a rubber duck which attaches to the base of the telescopic aerial, which, if you aren't aware, are about 1/8 of the range of the telescopic aerial. I'm told all the radios work. So, one of them has got a 100% fully extendable antenna. Number 2's got top section loose, and number 3's got top section missing, so that is useless. So, would you do a service on the good one? Yes, I will do a service on the good one. Then, he wants me to keep as a freebie, well, effectively the worst one. And I'm going to check over as a courtesy for that, for free. Check over, listen to those words. The other one, so he can sell it on eBay in whatever state it is. So I'm going to do the right thing here, and I will take the one with the broken antenna in the hope that one day we get a scrap AM set or something like that, which we can pinch the antenna off, because there's no chance of getting aerials for these. I think we have one of these somewhere. I may have even covered it before. So, that says top section missing 100%. No, it doesn't. That says 100%. Well, the best thing to do is to forget about the other two for now. What is great, I'm not talking about great Taiwan, is we do have the user manual, but is there a circuit diagram? No. So it's 8 throwaway batteries plus 2 dummies, or 10 AA's. So that means it's a 12 volt radio. It's 1 microvolt for 10 decibel SINAD. So I mustn't expect it to be better than it is on receive. And it's a 4 watt radio. And they've actually put the effective radiated power of 1 watt. Which is good and truthful. So it's very similar to the Harvard WT44 insofar as it has a rotary channel selector, it has a window there which you physically see the number of the bezel of the dial, and an LED simply shines through so you can see the number. And to be honest, that's all you want. The complication and expensive LED displays is, to me, a bit of a waste of money. Now, obviously you get out of the same factory as the Harvard 410 and lookalikes. At least we've got high-low power on the side. We've got the 2.5mm charger socket on the side. We've got extension, I can't even speak, extension aerial on the side. It's very similar to what the Realistic did here. And then we've got external power. So it's not, there's no ambiguity there. You know exactly what they are. And the fact that your charge socket is different to the power socket, you can't inadvertently put a 3 amp power supply and end up wrecking your batteries. So this is going to be his good one, no doubt. I'm going to carefully I'm going to carefully see that we can extend that antenna without tickling the camera's ribs. Yep. Oops. We did tickle the camera. So that is the I'm not going to dare let Mr. Chippy take this on a field test. These aerials are fragile, and that is the only time we're going to extend that while it's here. I'm sure we have one of these somewhere, but as I said, there's building work happening and a lot of stuff's in storage. So we've got a nice condition battery compartment. Nevertheless, I'm going to just run through that with the fiberglass brush unless Mr. Chippy has borrowed it back, which he might have done. I think we've only got one fiberglass brush between, what, 6 benches. Yeah, but we'll come back to that. So it tells us it's 12 volts, negative inner. So your pin is negative. That's very, very important. Have we got something to power it up with? I think we have. So this is positive. This little lead here is positive centre. So I'm going to have to make sure that I connect it up reverse. So the stripy one will now go to negative, and the black one will go to positive. And to be double safe, we'll power it up with the power supply in current limit to 80 milliamps. And we're powered up, so that's correct. Good. So the first thing we'll do, if I can find my little adapter lead. I sent the radio back which had the convenient plug, the KT750 Gson, so we were using that on his set. In fact, I nearly forgot to send that back and had to quickly shove it in the box. So we want to see what the radio's doing right now, and I'll write that on the back of the gentleman's letter. So this is quite easy. I mean, that's even the foam's in nice condition on that. So EU40 100%. That's the what we'll call this the 100% one. So I'll take the current limit to 1.5 amps and we'll switch picture in picture on, and if the second camera goes on to there we are. So we're going to put it on the 3-watt scale. Chances are it won't be beyond that. So I want to put this on channel 20. Now when I was 19 I could see these little things. But your eyes change at 40, don't they? That looks to be 20 to me. So here goes, transmit, and it is 2.6 watts. So TX power, we'll do 3 columns here, is 3.6 watts. Deviation, wallow, 2.3 kilohertz. That doesn't need altering at all. just for our own interest, low power is 510 milliwatts. I don't know whether it's adjustable on here. What else? Just for your interest, it's drawing 250 milliamps on low power, that's a quarter of an amp, and on high power it's drawing 550 milliamps. So it's actually quite efficient considering it's doing 3 point, did I say 3? It's not doing 3.6, it's doing 2.6 watts. What am I talking about? So let's look at receive now. So we want 2779.125 on the signal generator. So what we can do now we've got the lid open is to put it on frequency. And we'll just be doing the SINAD, of course, on this one because it's going to be absolute pain. So I've checked for schematic diagrams, I've checked for service manuals, there's nothing. I was going to compare the Harvard WT44 and there's no schematic for that, but I think we've got one on the shelf. So I'll just go over to the shelf. Yes, here's a WT44 with a clip-on rubber duck. Does that mean trouble? No, it doesn't actually, it just means rubbish range. So we're just going to open this one up. The WT44s came out about 1983. So you got the Harvard 410s in 81. These happened about 83. But I think the Eurosonic EU40 came about 87. I can't feel the screw down there. So I mean it looks the same. So we'll find out. We'll find out if we can get in. There is a screw down there. I wonder if it's had the... yeah, I'm having to use a bigger screwdriver because the nick's been rounded off. A real fun to get into. Yeah, I've got it to grin. Okay, so it's the same. And I noticed we've recently done a scratchy corner video. So apart from the layout, where the knobs are, it is the same radio. So it's a different printed circuit board to take that layout into consideration. That's good, that's nice to know. Of course it'd be nice if I could put it back together. You know what, I think they were $99.99 or something like that. They weren't cheap. The Harvards weren't. I don't know about the Eurosonics. We'll do that in a few weeks' time. There's no point doing a similar set one after the other. So we'll put the radio on frequency. So let's have a look at the frequency counter. There we go. 79110. Adjust the trimmer there. It's a nice quality trimmer. 127, 128, that'll do nicely. It's got room to drop. I'm going to switch the power off for safety, and by safety I mean I don't want to short anything out. I'm not going to get electrocuted by 12 volts current limited to 1 amp, but I don't want to damage the radio, especially with it not being mine. Somebody commented we don't have things like tweezers on this bench. No, we don't. Mr. Chippy has all the precision type tools. We don't normally do repairs on this bench except when we're doing a video. This bench is for alignment only. The bench behind me, bench 2, we do repairs on, and that has a more extensive array of test equipment. And we have shown that bench. I think we did the Fidelity 1000 partly on it, and we did the Fidelity 3000 when we wanted to try the sweep generator method. Of course, there's a sweep generator on there. There are 6 benches here, so you only see this one usually. Show Mr. Chip. Am I pulling something out there which I shouldn't be doing? I expect we've got to remove these knobs as well. You know, as a church organist, I have exceptionally strong fingers. And I can't get those off. I think they have to come off to get the board out. There's several methods to get these off, but well, it did move, but that's all I can say for it. What we can do is, because I take the top off, I can pry it out with a screwdriver without marring the finish. That's a method I hadn't thought of. You probably don't even need to take them off. Not sure that's one. I'm not sure that's one. There's one. What we'll now have to do is screw back all the ones I shouldn't have touched. And now we've got to the bottom of that speaker. So I'll put the power supply back on. So without service information, I can probably remember from a previous look that chances are that these are going to be the receiver. Perhaps that's the detector. I don't. In fact, I think there probably isn't a. You know what? I don't think there is a detector. I think it's done with 2 diodes. It's a very simplistic receiver. A bit like that G-Sync KT750 we sent back the other day. Okay. So hopefully I can Which one's it going to be? Is it going to be the orange one? It's the orange one. So where's that orange one actually go? Does it go up there? No. No, you see, it goes to the capacitor, which is under there. So you've got to take the speaker out if you're going to do the SINAD. So I'm going to have to hold this on. Well, I'm going to choose to hold it on. Okay, so we'll switch to that. And back to what we were doing to see what the SINAD actually is. It's actually three microvolts for 12 decibel SINAD. So that's not good, as you realise. So we'll see whether we can improve that. I mean, yes, it's going to hear, as we said, down to 0.3 of a microvolt, but it'll be with the increasing noise. So we'll run through these. Put a bigger signal on for that one. Have a look. I'm going to put the oscilloscope on just for my own benefit. So now we'll go back to these. That will slightly out. Just see what we're getting now. We're now getting 1.3. Now just check that this is nothing to do with the receiver. Would do if I could turn it. It is to do with the receiver. That's 1 microvolt, and we are getting, well, that's more or less 10 dB SINAD, and that's what the thing's supposed to do. But for 12, it's about 1.6. There's 10, 1.1 on that scale. Not quite there on 1, so it's about, yeah, it's about 1. And again, we can still hear it at 0.3. We can still hear it actually now down to 0.2. So that was worthwhile doing. At this point, I'm going to screw it back together. I don't know what got recorded there and what didn't. We seem to be in pause. I don't know that I've demonstrated this on the aerial, so we'll do it again just in case. 1 down a Roger. Okay, there's nothing there. 19 Roger. So we're going to do a on the air test with this. We'll keep it as it is connected to the power supply in the base station aerial. Mr. Chip will do the usual 6-mile run, and like the Harvard 410 and like that Kerno, well no it wasn't Kerno, was it? Gson KT750. Like that, as I said before, it's a simplistic receiver. They're not that clear when they're a bit further away. You can't expect miracles. They're not realistic 1001s. But we should get the 6 miles because it is doing 2.9 watts. We should be adequate to do that. So what I'm going to do, instead of saying goodbye, I'm going to check these other two out. We're going to write down on this form which is the best of the radios, and then I will go back into record and we'll discuss that. So in conclusion, having gone through the three, this is the third one with the broken aerial, and I'll retain this one. We had 2.6 watts to start with on the one we went through. It became 2.9. The one with the loose top section, which you could use if you were very careful, 2.6 watts. This one's doing 2.1 watts. Deviation's fine on all three. That was so off frequency, as a courtesy, I've just brought it up to spec. This one is near enough. A little bit deafer on that 1 microvolt, and that's what we can hear. I'm not starting to strip the board out to find out what it does in dB SINAD. This one can hear a bit more sensitive, but it's a really scruffy set with rust. You can see from the boxes have been stored damp. I haven't looked at the battery compartment on this, but this is the one we'll keep back, it being the worst. It's not so bad with the battery contacts. So I'll be doing the battery contacts on the one the customer's getting back spot on. And the other problem with the one with the loose top section is the power switch is broken in the on position. So to power it on and off, you either have to be connecting it to your external power, or you've got to take one of the batteries out. And that's a broken on and off switch within the volume control. It's not really something you can fix. You know, you need a donor set for that. And this one's got a very noisy volume control as well. So that's where we are with it. So that is usable and saleable, and as I say, as a courtesy, we just brought it onto frequency because it's quite a way out. So thank you for watching the Eurosonic EU40, and we'll see you on the air test.